Alright, so let's talk about standard form linear equations. I'm just going to demonstrate what standard form is by converting something that's in slope-intercept form into standard form. So let's just take the equation y equals, why don't we say like y equals negative 3x plus 2. And to get it into standard form, we just want the x and the y to go over on the left side and the constant on the right side. So variables on the left equals constant on right. And we want the variables in order. So let's add 3x to both sides. We'll write 3x plus y equals 2. So that's the slope-intercept form. This is the standard form. The usual gripe about standard form is that, well, we've got like everything we need in slope-intercept form, right? So like, why do we have to convert it to this? Yeah, maybe this looks nicer in some way. Does it really though? I don't know. But we've got like our y-intercept at 2 and our slope at negative 3. So we can just draw a line like that, right? Well, there's actually something that's kind of cool about the standard form. And that is that you can see both intercepts really easily in the standard form. In this form, in slope-intercept form, you see the y-intercept here, but as far as the x-intercept, well, you've got to kind of solve for it. You got to set y equal to 0 and then be like 0 equals negative 3x plus 2. And then negative 2 equals negative 3x, then 2/3 equals x. Okay, so then that would be 2/3. But in standard form, I'm just gonna write this. In standard form, you can see that right off the bat. So like you can do 3x plus 0 equals 2. X equals 2/3. Similarly for y, 0 plus y equals 2. Y equals 2. So what ends up happening, you just have to divide whatever coefficient you have here, or divide the constant by whatever coefficient you have there, and then again by whatever coefficient you have there. And then once you have the two intercepts, y is 2, x is 2/3, you can just plot them and then draw a line straight through them. I actually like this method a lot better than slope-intercept form, just because I hate trying to get the slope about right. Like here, so I plotted it at 2, the y-intercept, and then I tried to draw a slope of negative 3, but it looks like I didn't do that too well, because it should have been actually a lot closer, a lot steeper like that, because the 2/3 was supposed to be the x-intercept. Yeah, so I didn't really do the line too well. But here I've got a better idea of what kind of shape I need to give the line. Like I actually have 2 points here that I can just connect and then not even worry about getting the slope right. So it's really just connect the dots here. I like it. So let's do another example of how to do this plotting in slope-intercept form. So let's say that we have 8x plus, actually let's make it minus this time, 8x minus 4y equals 1. Yeah. So let's just get the intercepts here. So to get the x-intercept, you have to plug in 0 for y, and you get 8x equals 1, so we really just need to divide 1 divided by 8. And then the y-intercept, same idea, 1 divided by -4. Now, if we were doing the slope-intercept form, then it'd be kind of rough having to deal with these kind of small fractions and get our axes right. Yeah, maybe we'd end up like making the scale wrong or something. But here we can just, we got an idea of what 1/8 is, got an idea of what -1/4 is, and then can plot. Let's just make -1/4 here, because we know it's bigger than 1/8, and then 1/8 can go up here. And then we've got our line.